Welcome to lesson 5. Now we are looking at linear and exponential change. In SAT we have, let's say, two types of change. First one is linear, let's write here, and exponential. Okay, let's write general form. Y is equal to a plus bx. When you see this type of form, it means that it is linear. When you see this type of form, a is a multiplied by b with power of x, it is exponential. So x is here exponent, that's why it's called exponential. Another name for linear, you can think it like it is algebraic sequence. Maybe you see it from in the school. For exponential, it is geometric sequence. Okay, now let's give an example. Let's look what's the meaning of linear change. We learned actually linear functions, so they are same thing. For example, let's say we have a $1,000 and we are saving money for every month, and we are putting $100 from our wage every month, so it is plus 100 months. Let's look at the graph. We are starting from 1,000 and it increased by $100 per month. So for starting, for let's say zeros week, it is 1,000. For first, after in zeros months, it is 1,000. After 1 month, it is 1,100, 1,200, and it goes like this. So it is always plus 100. So when it increases with addition, it is a linear. Sometimes you can see something like that. For example, it increases by 100 here, then increase by 101 here, then for example increase 99. It's also, we can say it's also linear. So they are similar to each other. When you have a, for example, bigger number like population of Azerbaijan, let's say, and it increases, for example, 100,050 people this year, and next year it increases, for example, something similar to it. It's also linear. Let's continue with exponential. For exponential, let's say that we have a 1,000 and we are putting it to bank and we are getting 10% increase every year. We learned that 10% increase is multiplying by 1.1. We will look at this type of this investment word problems after linear and exponential growth. Okay, here we start from 1,000, then it increases like this. After 1 year, for starting it is 1,000, after 1 year it is 1,100, then it will be equal to more. First it increased by 100, then it increased 110, then it increased by 121. So you can see that they are not same. You have to think it like this. Every time we multiply it by 1.1. So when you multiply it, it's called exponential growth. Let's write here, for when it increases with multiplication, it is exponential growth. When it changed, let's say it changed with division, for example, every time you divide it by 5 or every time you multiply a number between 1 and bigger than 0, it's called exponential decay or exponential decrease, same. Let's write it like when it is b is greater than 1, when b is greater than 1 but less than 0. So this one is exponential growth, but when it is like this, it is called exponential decay. When it is like this, here maybe you can see that b is greater than 1, that's why it's exponential growth, but it is not, because we have here negative sign. You have to think it like this: 1000 multiplied by 5 is negative 1 x, and for this expression you can write 1000 multiplied by 0.2 x. So because it's less than 1, it is exponential decay. And here 1000 a is always initial. For example, you have this type of model. Let's say it is 0.7 and here x. I don't want to talk about linear change because it is very simple. There is no more thing. It is same with linear function. That's why let's concentrate on exponential change. Okay, here sometimes they can ask, what's the interpretation of 1000? 1000 is always initial value. Initial starting or setup value, same thing. When they ask what's the meaning of y or interpretation of y, it is final value. When it asks 0.7, it means that it factored by, for example, if x is number of years, it factored by 0.7 every year. Or proportion or fraction remained after 1 year. It's also same. Or let's convert it to percent. It is 0.7 minus 1 multiplied by 100. So it is 30% decrease. It means that it decreases 30% per year, or each year, it's also same. Okay, now let's look x. X is always time related. Let's say y is equal to 1000 multiplied by 0.7. Let's write t here. Or let's write it. Let's write a little bit different equation. Y is equal to 100 multiplied by 2, and let's write here t. Okay, here t is number of years. Okay, let's look difference between this model and this one. Y is equal to 100 multiplied by 2 with exponent like 2t. It means that, let's write it like this. Okay, here after 1 year it will become to 200. So we can say that it doubles every year. But here, because there's another 2 here, after 1 year it will become 400. For this one, because of this 2, we can say that it doubles twice every year. So it is the difference. For example, if it is like this, or actually you can say that it doubles every 6 months. It's also same. For example, if you have 60 there, like y is equal to 100 multiplied by 260. You have to divide 12 months by 6, you will get 2 months. So it doubles every 2 months. Or let's think with hour. You have a model like this, 100 multiplied by 0.520, but here t is number of hours, here is hour. Okay, for 1 hour it is equal to 60 minutes, so you have to divide it by 20. It means that it halves every 3 minutes. I hope it is clear. But let's look when it is division. 100 multiplied by 3, let's say it is t over 5. When you write instead of t5, let's say t is number of months. Let's write number of years. Okay, when you write instead of t5, you will get 300. So here you can say that it is it triples every 5 years. I hope this understand. Maybe it seems like a little bit different or difficult. Just put a number. It will make you understand how it changed. But when it is division, it means that 5 years. When it is multiplication, it means that it is every 3 minutes. Okay, now let's look converting. Like y is equal to 100 to with power of t. T is years. Okay, now I have a m. M means number of months. I have to convert it to number of months. Let's look how to write it. Y is equal to 100 to, okay, here in exam or in question you will see one option like m over 12, m multiplied by 12 for here, m plus 12 and m minus 12 probably. This 1 is wrong. You can cross it. Now let's give a value. For example, let's think t is 1. When t is 1, y is equal to 200, right? After 1 year pass, 12 months will pass. So you have to write instead of m 12. For this one you will get 1. So you will get here 200. But here you will get 144. It is very big. It's a big number. So we can say that it is m over 12. Okay, now let's convert it, for example, days. For days it will be y is equal to 100 multiplied by 2. Let's say we have a 365 days in 1 year. D over 365. Okay, now convert it to decade. Okay, decade means 10 years. It is y is equal to 100 multiplied by 2 d over d multiplied by 10. Okay, now this 2d is not same thing. When you write instead of d1, when 1 decade pass, 10 years will be passed, so here will be 10. Here you have to write 10. It's also 2 with power of 10, so they are same. Let's convert it to century, and it is last one. Y is equal to 2 multiplied by 100. Let's say c multiplied by 100. I'm sorry. And c is number of centuries. So here when you converting to smaller period like months, days, you have to divide it. When you convert it to bigger period like decade, century, then you have to multiply it by this number. Its number, let's say. Okay, we talk about x. Now let's look how to identify is it exponential or linear. Okay, when it increase or decrease, let's write change with unit. Like, for example, population of Yevlach increase, for example, 1000 per year, or a tree increase 5 centimeters per month, or another something like that. You have a unit here, for example, this one is 1000 people, 1 centimeter, or etc. These ones are linear. When it change with percent, like population of Lancharan increases 10% every year. Or for example, we have a radioactive matter decreases its weight. Radioactive matter decreases its weight by 5% every hour. These ones are exponential. But there's a one case when there's a, for example, 10% of initial or original starting value, it is linear. Let's look some keywords. When you have doubles, triples, quadruples, or something like that, they are exponential growth. When you have halves, half-life, and etc., it is exponential decay. When you have this type of question, I see it from Blue Book. I think Blue Book. F of x is equal to 200% of x. So it is f of x is equal to 2x. So it is linear. Okay, this type of question is very popular in SAT. If you understand this part, I think you can write all of them correct. We didn't talk about graph of exponential and growth and decay. For exponential growth, we have this type of graph. First, it increases slowly, then it increases rapidly. For exponential decay, first it decreases rapidly, then slowly. Now let's give an example. For example, most popular example for exponential growth is increasing of bacteria. You can see this type of question. Bacteria doubles every hour, for example. Or for example, there's a news in social media and okay, I can't find the exact word, forgot this. For this one, most popular example is radioactive matter decreases its weight by 10% every year or something like that. Also we have simple and compound interest. It's also, one of them is linear, one of them exponential. Let's look them. Okay, let's start with simple interest. For simple interest, let's say that you have a $1,000. You are putting it to bank and you are getting 10% of $1,000 every year. So after 1 year it is 1,100. After 1 year again you are getting 100. So it is like this and like this. It's called simple interest. It is like this: 1,000 plus 1,000 multiplied by 0.1 multiplied by number of years, or we can write P is equal to P0 plus N R, not N, P0 plus P0 multiplied by this one, annual interest, and T number of years. Okay, now let's look second case. It is called compound interest. You have 1,000, you are getting 10%, so it is 100. First one is linear, second one is exponential. So you can see that there's a $31 after 3 months, $31 difference. Here it is let's say final amount of money is equal to 1,000 multiplied by 1.1 with number of years. General equation is P is equal to P0 multiplied by 1 plus R and T. Probably you know this one, but this one generally they don't ask. I rarely see this type of question in the exam, but let's talk about it. You are putting $1,000, but you are getting your payment after 6 months. You are getting payment twice in a year, but if it is 10% after 6 months, you will get 5% of it. So you are getting additional $50. It will become 150, and after 6 months it will become a little bit more than this one. So there's a $2.5 difference. For this type of question, you have an additional N in the formula. N is number of payment in year. For example, it is, if it say you are getting your money every 2 months, it means that you are getting 6 times in a year, so N is equal to 6. When it say, for example, once in a 2 year, it means that N is equal to 0.5. When it says semi-annually, it is N is equal to 2. But it is not popular question type, that's why I don't want to talk about this one. Last thing I want to add, you have to be careful about this type of question. For example, I saw this question in 2023 US SAT exam, April or June, I don't remember right now, but it's something like that. He is getting 50 from his first trial. And after every trial, he increased it by 10%. What is his score after in fifth trial? Okay, because it increased by 10%, it is like this: 50 multiplied by 1.1, and here number of trial. Most of time, when I make a trial exam in my college, let's say in course, most of students write here 5 and do mistake. But because we say first trial, it's not starting, it is not 50 actually. It is the amount of value when you multiply it by 1.1. So you have to write here 5 minus 1. So it is the correct answer. So you have to be careful about A. What's the initial value? 50 actually not initial value. 50 is value of y when x is equal to 1. So be careful. Thanks for watching. See you in next lesson.